Hey everyone, welcome back to the channel. So this is the fourth session of Pandas library that we have started, and in those three sessions what we have covered up, we have covered up like introduction to Pandas library. Then we have seen introduction to Pandas data frame, what is actually data frame, and then we have seen like how we can create Pandas data frame. And in the last session we have seen what are the methods and attributes available in the pandas data frame. Now from this session what we are going to start, we are going to start how we can work with CSV files. Now how we can import a CSV file to any like environment like collab notebook, and how we can convert that into a pandas framework, and then how we can interact with those pandas data frame with the help of some pandas library and the methods and functions attached to those libraries. So before we start converting a CSV file to pandas data framework, first of all we need to know what is actually a CSV file. So the full form of CSV is actually comma separated value. So why we call that CSV? Because you can see how a CSV data actually look like. So if you have seen like an Excel file, the similar way it look like, but the difference is in Excel file you have like rows and columns, and all are there are cells present, and inside that cells you have values. But here all the values are separated by commas. Like this is one row, you can see, but every value is separated by a comma. So this is actually a column header name, age and city. And then you can see after that in name you have value John, and then age you have value 25, and in the city New York. Similarly you can see Jane 30 San Francisco, then Bob 22 Chicago. So all of these value are actually what, comma separated, you can easily see. So there are no any lines here to separate them as a rows and columns. But since you have rows, yes, this is the first row, this is the second and third, but the values are separated by comma. That is why we call that comma separated value. So let's see how we can import a CSV file to our collab notebook. So first of all we need to know that where is our actually file present. So either in Google Drive or in local file, wherever present we can just import it. So there are two options, either in let's say you are having file in Google Drive or you are having in local file. So there is an option, you can see these files where you can see all of your files that is present here. So first of all if you want to upload any data to here, like you can just click on this button and you can just select any file that you want to upload here, and after that you can just upload that CSV file here. Otherwise if your data is present at the drive, what you can do, you can just click on this button. Since I have already connected with the drive, you can see there is an option of unmount drive, but if you have not connected, it will say mount drive. So if you just click that, it will ask for the permission and it will be available here. So you can see my drive is accessible here. And there is an alternative way also to mount the drive. Like you can just write the code here from Google Colab, import drive, and then drive.mount content drive. So this will just mount your drive here. And then what you can do, you can just import the libraries. And then so now since you have imported your Google Drive, now what you can do, whatever the file that is present inside that Google Drive, you can just import it here. So let's say in my Google Drive, if I just open it, what you can do, you can just click on that, and then after opening that you can just open your drive and you can locate your file actually where it is present. So let's say in my drive I have a folder called data, and inside that I have a let's say data that is called menu. If I just found that, let me see where it is. So here it is. So this is the menu data set that I want to import here. So what you can do, you can just click on three dot, and then what you can do, you can just copy the path. After copying that, you can just click the cross button, and then what you have to do, let's say you want to give a your data frame name. So let's say I'm giving the menu df, since it is a data set related to a let's say menu that is having some of the items and item description and price, ingredients, all of this kind of thing. So I have given the name menu df. Now how you can import that, you have to just do pd.read underscore csv. Since this is a CSV file, you have to write read underscore csv. If that is an Excel file, so what you can do, you can just write pd.read underscore excel, and then you can give the path that you have copied. So whatever the path that you have copied, you have to just put that into a single inverted comma, and yes, you can just run that code, and yeah, your data frame has been imported here, and it has been converted into a pandas data frame. Now you can easily interact with this pandas data frame. So how you can interact? So whatever the methods and attributes, whatever you have seen, you can just use it here. So you have seen the dot head. So what you can do, so this is the data frame we have, menu df, and on that we can just apply dot head, and if I just run that, you can see it will just give some of the top 5 rows. So you can see all of the columns we have, and top 5 rows we have. So what are the columns we have? The first column is item id, and then item name, and then item description. So item id is actually a unique id we have for each items. Then item name, like noodles, rice, beef, pork, desserts, all of these kinds of items we have. Then item description is mouth watering dessert, like what kind of item it is, just the description of that item. And then the type of that item, so it comes in under a dessert or appetizer or drink, all of these things are mentioned here. And then item price is also mentioned, and what are the ingredients for that item, it is also mentioned here. And then how much calorie it will give, then rating of that item, then sales count, how much it has been sold, and what is the cost per item. So for each item, what is the cost of that item. So this is what we have as our data set. So whatever we will see in this video, we are going to directly interact with this data set, and we are going to learn many things using this data set. So let us start with after doing head, we are going to start with dot info. So you know dot info. So dot info will give just a brief info about the data set. So what are the columns you have, then what are the null counts we have, then the data types of each column, what is the range of indexes we have, and what are the memory usage, all of that kind of thing is shown here. Next we are going to look at some of the columns, like you can see if you just print a dot info, so you can easily see what are the columns. But if you want to see the columns in a list, you can just do menu df dot columns, and then you can convert that into a list using that list in the outer braces, and this is the list of columns you have. Then you can check the shape of the data frame. So you can see menu df dot shape, it will say 1000 comma 10, that means you have 1000 rows and you have 10 columns. Then you can also check the type of menu df. So it is obviously a data frame, so pandas.core.frame data frame. So you have, then what is that thing, writing a csv file in the location. So you can also write the csv file. So how you can write a csv file, you have to just do like whatever the df you have, let's say you have made some changes to that menu df, and then after you have saving it. So for now I have not made any changes, but I'm just showing it how you can save that. So pd dot to underscore csv, and then you have to give a file name. Let's say if I have updated that, I will say updated menu df, and then you have to also give the extension of the file name, so it will be .csv, and then you have to give another argument that is called index equals to false, because you don't need an indexes, whatever the indexes you have 0 1 2, that you don't want that as a column. So we'll just say index equals to false, and yes, that's it. You can just run that. So after running that code, you can just check it here, whatever the file that you have saved, it will be refreshed here. If I just click on the refresh button, you can see updated menu df.csv. So you can just click on here 3 dot, and you can just download it or copy the path or save wherever you want. Cool. So till now what you have learned, you have learned how to import a csv file, then convert that into a pandas data frame, and then some of the methods that we use to generally look at the data, like dot head, dot info, and then dot columns. All of these things you can use to see what kind of data it is, what is the shape of that data, and all of these things. Now what we are going to learn, we are going to learn some of the pandas operations. So what are the pandas operations we have, like indexing and slicing. Now what we are going to learn, we are going to learn pandas operations. So what are the some of the pandas operations we have, like first of all we are going to start with indexing and slicing. So as we have seen like indexing and slicing in other kind of data set like in list and in a string also you can do all of these things like indexing and slicing. In a similar fashion, if you have a data set like a pandas data frame, then inside that also you can do indexing and slicing. So what does it mean by indexing and slicing in a data frame? So in a list and a string, what you do, you took some of the elements and some of the characters out of that, but here in data frame you will choose some of the rows and columns, because data frame is actually what, a combination of rows and columns. So if you are doing indexing and slicing in a data frame, it means that you want some of the particular rows and particular column values. So you can do that thing with the help of indexing and slicing. So this is the data set we have. Again, I have just used menu df dot head. So this is the top 5 rows we have. Now we are going to look at how we can do indexing and slicing in data frame. So first of all, we are going to look at iloc. So this is the method that we are going to learn. What is a dot iloc method? So using that, what you can do, it gets rows or columns at a particular position in the index and takes only integer as an input. So what is that thing, only integer as an input? Why I have just highlighted that thing, I will tell you. So it will be just clear in a while, just wait. So first of all, we are going to look at what is dot iloc method. So you can see this is the menu df we have. Onto that I have applied dot iloc. Now for indexing and slicing, you already know that you have to give a square braces. So after giving a square braces, there are two values that I am giving, so separated by commas. So first is the for the range of rows we want. So if you want the rows like from 0 to 7, means you want top 8 rows. So in that case, what you will give, 0 colon 8. So that means it will start from 0. Since you have not giving any a starting index, it will start from 0 by default, and the ending index is what, 8. So since it is excluded, it will go up to 7. So it will fetch the first 8 rows starting from 0 to 7. Now the second value is what, after comma you are giving a second value, that is for columns. So for columns you want from 3 to 5. So it will start from 3, but it will go up to 4. So if you just see the data set we have, the first column is what, this one, that means at the 0th index. Then this is the first, this is the second, and this is the third index. So this is what index that we want, from third index up to fourth index. So item type and item price, these are the two columns that will be filtered out here, and the rows will be from 0 to 7. So you can see what is the value that we are getting. If I just print that, you can see I'm getting the value from 0 to 7, that is the rows, and column we are having only item type and item price. So this is what, this is a kind of slicing we have done in our data frame. So this is the whole data frame we have, not this is the whole, this is just the first 5 rows that I am showing it here, but there are total of 1000 rows, but all columns are present here, you can see. So inside that we are just slicing the data set, and we are getting this part of the data set that we want. Now this was using dot iloc method, but there is another method that is called dot log. So instead of iloc, you will be using dot log. So what is the difference between them? So the difference between them is that in dot iloc you can just use integers as an input. That means whatever the columns that you want, you are just giving the indexes of that column. Now it might be possible that you don't know what is the index of a column. You will be not actually counting now. Let's say you have 100 and thousands of column. So in those cases, if you want some particular column, you will be not counting that at which index that column is. So in that scenario, you can just give the name of that column itself. So in that case, dot log becomes essential. So you can see in menu df I am using dot log, and I am giving the rows. That means I want from 50 to 60 rows. Now one thing you have to notice, that whatever the value that I am giving here, 50 to 60, that is not actually treated as a integer value, and it is not treated as a index value. It instead, it is just taking the name of the indexes. So if you just see here in dot iloc, you can see if you are taking from 0 to 8, it is going up to 7 only. That means 8 is excluded. That means it is taking that as a range of value for which you want. But here it is not the range of value, it is not the range of value that you want from 50 to 60. It is the name of that indexes itself. So you can see the rows that I'm having is the from 50 to 60. So you can see 60 is not excluded, it is included here. So this is the just a name of the indexes here. So it might be happen na, that instead of having a numerical indexes, you are having some uh, alphabetical or something else indexes. So in those cases you can just give the name of the indexes, just like for columns you are giving. So for columns you are not giving here the integer values, not the indexes, you are giving the name of the indexes itself. So for let's say you want item name, then rating, then item price, let's say you want 3 columns. So you have to just provide those 3 columns in a list, and that will be filtered out here. So you can see how easily you can just filter out the values here, and this is the result that we are getting. Next, let's say in the same fashion I'm using that dot log, but I'm not giving the starting and ending indexes of the uh, not the indexes, actually name of the indexes of the rows. So in that case what will happen, all the rows will be fetched here. So you can see from 0 to up to 999 has been fetched here. So in this case, if you're not giving any indexes, you're starting an index ending indexes, so in that case all the rows will be fetched out. And for column, let's say you are giving the column name, that is why you are getting only 3 columns. Now let's say if you want the all the rows and just a particular columns, so you don't need to use dot log in that case. If you want all the rows itself, you don't need to use dot log and give the indexes like that. But instead what you can do, you can just take the menu df and you can just give the square braces, and inside that square braces you can just give the list of the columns that you want, and yes, that is fine. And after that you will be getting the uh, 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 filtered rows and filtered columns. So not rows, or rows will be all there, but the columns will be filtered, and you can just apply dot head on dot tail, whatever you want to see the data set. So since I'm applying dot head 10, you are having the top 10 rows. So I'm really sorry about the background noises. So I don't know, some dogs are barking. I cannot stop them, but I hope I'm clearly audible, so there will be no any problem. So yeah, in fact we can also perform the Boolean indexing on our data frame. So what is that thing, Boolean indexing? So in Boolean indexing what you can do, let's say Boolean means what, true or false. So based on the conditions you can also filter out some of the rows. That means you can do indexing based on the Boolean values. So let's say menu df, in menu df you have a column called item type. Now in item type you have many values you have. So let's say for item type, if you want to see what are the unique values you have for item type, what you can do, I will just write a simple code. So I know that I have not introduced that thing, but yeah, I'll be using that thing to just to show you what are the unique values you have. But at a later stage you can just see what is that thing, value count. So it is again a kind of method that I am using to get the unique values here. So you can see we have 4 type of item types: dessert, and then entry, and then drink, and appetizer. So all of these things are present here, and this is the value counts. That means what how many values we have for dessert, and how many entry we have for like entry, drink, and appetizer, of all of that thing. So let's see what you can do. If you want to filter out the item type, that means if you want to get the data set that is having only dessert as an item type, so what you can do, if you just set menu df dot item types, that means menu df a square braces, and inside that you can just pass out the column item type and equals, that means dessert. So you are just comparing that item type is equals to dessert. So in that case, if you just print that to see what is happening here, so for each of the rows you can see from starting 0 to 999, all of those rows are getting a Boolean value. That means in 0th row, is it true? That means is the item type is dessert? So yes, it is true. But in the first row it is not true, that means their item type is something different. So it might be drink, appetizer, or entree and something else, but it is not dessert. But for the second row also it is false, and third and fourth it is true. So this is how it is going on. So now if you want all the rows that is having item type is equals to dessert, so what you can do, you can just do, let's say you are just giving a name of the data frame. So whatever the new data frame that you will get, that means the filtered data frame that is having only dessert as an item type. So in that case you can just give the dessert items as a let's say file name or a data frame name for your data frame. And then how you can filter out, so menu df, you have to just keep the menu df, then a square braces, and inside that you have to pass out that condition, menu df item type equals dessert. So you can see, first of all we are just filtering out menu df item type equals to dessert, so it will just reject this one. And then after that I am again doing a indexing of menu df and then square braces of this condition. So it will just filter out all the rows that is having a value equals to true. So that means the boolean value, wherever true that is present, it will just fetch out all of those rows. So you can see, if I just print that, if I just dessert items dot head, it will just print the top 5 rows. So you can see all of those data set, that is data frame, whatever the values present here, all of those are having item type of dessert only. So you can see the top 5 rows we have, all of those are value dessert. So if you just want to check out that how many rows you have fetched, you can just check the shape of that dessert item, and it is 279. So you can just match this thing from here also. You can see the dessert was actually what, 279 entries we have for dessert. So the same thing is coming here. And similarly, if you want that filter out all of those rows which are having not item type as a dessert, so here what you are doing, you are comparing equals dessert. But if you don't want the dessert item type, you will just say not equals to dessert. In this case you will be having item type anything else except that dessert. So you can see drink, appetizer, entree, all of these things are present, but dessert is not present. And if you just check the shape of that, so non-dessert items, it is 721. So it will be just summation of all those things, like 243, 240 and 238. So you can just validate out. So next what we are doing, so that was about equals and not equals, but we can also compare that with some values. So let's say you want to filter out all of these data set that is having rating is greater than 4. So you want all of those item names that is having greater than the rating having greater than 4. So what you can do, high rating items equals to menu df. So the same, in the similar fashion, menu df and then square braces, and inside that you are giving the condition of that rating equals rating greater than equals rating greater than 4. So you can see menu and then rating greater than 4. So this will just fetch out all the rows having rating greater than 4, but you want just item name and rating. So that's it. So in that case you are just giving another filter. So high rating items you have just fetched out, and then on that item, high rating items, you are just filtering only the 2 columns, that means item name and rating. So that is why you are getting only 2 columns here. And you can see for all of those items like noodles, beef, fish drink, chicken drink, all of these things, the rating is greater than 4. So that is how you can just filter out this kind of thing. And you can see the rows are having 235 and there are only 2 columns, and these are indexes. So you can see there are different indexes, no, 5, 9, 10. So this is what actually this is, that means all of those values are not actually fetched out, only those values are fetched out that is having rating greater than 4. So that is why that indexes are not actually serial. So that was about condition for greater than and lower than. And in fact we can match conditions for multiple columns. So that is not the thing that you are just matching the condition for a single column. So you can just do for the multiple columns. So how we can do that, you have to just add a end statement in between. So you can see menu df and then the square braces, and inside that I'm giving 2 conditions. So menu df item type equals to drinks, that means I want all the items that is having item type equals to drink, but I want all the drink item types along with rating having greater than 4. So that means you want to give a and condition. You can also give the or condition, and you can also give the and condition. So for and condition you have to just add this ampersand and remember one thing, whatever the conditions you have, like two conditions, you have to put that into braces. So round braces, you can see this one is again in round braces and this one is again in round braces. So if you don't give that, it will fetch an error. So that is why you need to keep that. And if you just I've just give the name of the first items as a best rated drinks, and you can just give the head of that, and yes, these are the best rated drinks, and you can see the rating is greater than 4.5 for all of these things. And what are the item description you have, like delicious drink, satisfying drink, healthy drink, hearty drink, mouth watering drink, all of these things, all of these drinks are having rating greater than 4.5. And if you want to check out that how many drinks are like those type of drink, you are having total 30 drinks. So this was about and condition. If you want to give the or condition, what you can do, instead of and, you have to just give the or condition like that. So you have to just give that line, and you can just run that, and you can see this is the result we have. Now if I just check the shape of that, you can see it will be bigger than that 332, since it is what, it is an or condition. So either of them are true, like either the item type is drink or the rating is 4.5, all of those results will be fetched. You can see item type is not necessary that it will be drink, so there is one appetizer also, because it will be having a rating greater than 4.5. So you can see rating is 5, and it is also not necessary that all the rating will be greater than 4.5, since if this condition true, you can see this is drink, so it is not required that rating is 4.5 greater than 4.5. So you can see 1.69 is the rating. So that is how you can use or and condition based on your choices. Next, let us see how we can manipulate the columns. So we can create new columns from the existing columns also.